Hello out there. Welcome today on this beautiful day. Hope you're ready to work. We'll be looking at some statistics, but the focus will be on data handling. And my name is Rakabu. I'll be taking you through some of beautiful statistics with us. Okay. So the focus is 5-number summary. But before we do that, I'd like you to think about something. I'm not sure whether you've ever thought about it. How can one predict the rand to dollar exchange rate in future? Can we really predict? I mean, if the rand is to a dollar is 15 rand, maybe now, can we really predict what does the rand look like in future? What information do you need? Can a different bank come to a different conclusion? You need data. Do you need 10 days data? I think that's little data to predict. You need lots and lots and lots of data to really predict. And sometimes to sketch a line graph and look at the trend of the rand. I mean, you might be traveling overseas and you want the best time to exchange your rand to dollars. Okay. So that's one of the important part of data. Okay, so I hope you've thought about this and how can one predict the rand to dollar. Okay. Another thing to think about is how does an insurance company decide on car insurance premium? Okay. I mean, when you buy a new vehicle, a car, especially if you're taking a loan, even not in cash, you have to have an insurance because you'll never know what might happen on the road. That we pay different premium. How does an insurance company decide on that? Actually, they use data also. Okay, I mean, they study where you live. Some company will put a device in your car and check how you drive and really predict your premium. Okay, so data is very important. It can be in predicting rand, it can be in forecasting your insurance premium. Okay, great, fantastic. So what we're going to look at now is we're going to look at 5-number summary. And under 5-number summary, we'll focus on quartiles. Then look at the box and whisker plot. And so if you look at this, I mean, we have measure of dispersion. Remember the measure of dispersion, there will be the interquartile and the range. And the measure of central tendency will be your mean and median mode. Okay, they get the cluster around the mean. Okay, so but the focus today will be mainly the measure of dispersion and the 5-number summary. Okay. So we'll look at the interquartile range, and semi-interquartile range. Okay. Let's look at some keywords: minimum and maximum. What is a minimum value and what is a maximum value? If given set of data, the lowest value is a minimum value and the highest is the maximum. Why do we care about the minimum and maximum? I mean, they're very important. We can study whether the data is so consistent. Okay, I mean, let's say for your maths results, your test 1, you get 20%, test 3, you get 90%. Your maximum is 90, your minimum is 10. I mean, is that person consistent? I think that's inconsistent. From 10 to 100, one can say you're improving. But let's look at student B. The first test, he get 40%. Then the next test, he get 55%. Oh, the minimum is 40%. The maximum is 55. The deviation between the minimum and maximum is just not too much. I'll say student B is consistent. So it's important to know the minimum and the maximum value of the data, which is the lowest and the highest value of this given set of data. Fantastic. I hope this makes sense. Then let's look at more keywords. So we have extreme and skewed. So we have extreme value and skewed. What is extreme? So extreme value in data handling statistics will be your lowest and the highest value. This just doesn't fit within the data, the extreme value. Okay? Does that make sense? I mean, imagine in a class, everyone gets 50, 50, 50, 50. Suddenly someone gets 2%. I mean, 2% is extreme, which is the lowest from the whole of the class. And imagine in a class, everyone gets 40, 30, 40, 30, then someone gets 99%. 99% can be an extreme value. The extreme values, what do? They can actually affect your mean. Because think about this, if I, in between, have smaller values, then someone gets 100%, the average can be higher. So it can really affect your average. And also imagine if I have 3%, then the 40s, the 3% will lower the average. So the extreme values, which can be the highest one and the lowest one, they have an impact on your average. Okay, fantastic. Hope this makes sense, which is your extreme value. Now let's look at skewed. What is skewed? Skewed, we might have data which is skewed. If you look at the median, which is the middle of your data can be on, let me draw, let's say the median is here. We have median, which is there, which is the middle. So more of your data can be this side, which is more of the data, and let's say equal, actually. So you have same, this side of the data is the same as this side. So that will be symmetrical, because there's the median, this side is the same as this side. It's symmetrical. But now, what if this side is not the same as that side of data? So that is skewed. So it could be skewed to the left or skewed to the right, depend how I move my median. If I move median there, it'll be skewed to the left. If my median is somewhere there, it's skewed to the right. Okay, so skewed is about the distribution of the data. Okay, that makes sense? It implies you can have more students getting above the average, or more students getting lower marks, which are skewed to the left. Okay, fantastic. Hope this makes sense. The extreme value and skewness. Okay, but we'll discuss this in details later also. So we're going to look at our 5-number summary. We'll look at range, the box and whisker plot, interquartile range, and these are the measure of dispersion. And this part focuses mainly with our quartiles. Okay. So 5-number summary. Now we're going to look at 5-number summary. So what is this 5-number summary? 5-number summary is just a way of summarizing data using 5 values. I don't want data, as you present data to people, you're not going to give them 100,000 of data. You're just going to, they want 5 summary. What is 5 summary for the data? We want the lowest value. We want the highest value. Okay, let's look at that. You want the minimum, the lower quartile. And remember, the lower quartile is actually 25% of your data. Okay, does that make sense? It's the quarter of the data. So the minimum value, lower quartile, then median, median, which is the middle number given set of data, okay, which is actually the first 50% of the data, which is a median. Then followed by the upper quartile. So the upper quartile, from minimum value to the upper quartile, or Q3, it's 75% of the given data set. Okay. Then we have our maximum value, which is the last one. Okay. Why do we need this? Instead of presenting 1,000 data set, you calculate the 5-number summary, and from the 5-number summary, we can do some analysis and arrive at some conclusion. Does that make sense? Okay, beautiful. So, what is the median value? So, the median is Q2. Okay. The median value is denoted by Q2 for us. Is the middle number once the data has been written in order. Written in order, we mean from the lowest value to the highest value. Then the middle one is our second quartile, or the median. Okay. If there are n numbers in order, the median lies in position half n plus 1. Okay, what is n? If I have 10 set of data, n will be 10. So it's 10 plus 1 is 11. 11 divided by 2 will be 5.5. Then position 5.5, I'll find my median. I will use this formula if you have a large data. If I have a small data, I can arrange from the smallest to the highest and actually find my median. Okay, makes sense. Then now let's look at the lower quartile. This value lies 1/4 way through the ordered data. So we have the median. Then from the minimum value to the median, I find the median. That median, we call it the lower quartile, or Q1. Also, we can use a formula to find the position of the lower quartile, or Q1, which is quarter is n plus 1. When n is 1, when n is the set of data, if n is 10, you put 10 there, divided by 4, that will give you the position of the lower quartile. Or you can just arrange the data, then the lower quartile, you'll find the data point there. Okay. So now let's look at the upper quartile, or known as Q3. So this lies 3/4 way through the distribution. Distribution means the data. Does that make sense? So we have lower quartile, which is the quarter of the data, median 50% of the data. Then 3/4, we get the upper quartile, or Q3. We can use this formula also to find it. 3/4 n plus 1. N is the size of the data. Then that value gives you the position of the lower quartile. Then you actually go and find it there. Okay. So guys, I hope it makes sense. So we'll see you after the break, and we'll continue with 5-number summary. Fantastic.